Welcome back. So previously we were discussing about three inventory models. So this is the last model, that is a manufacturing model with shortage. So we'll be combining the manufacturing model without shortage with model 3, that is purchase model with shortage. So as you can see, here there is a possibility for stock out to occur. So we'll start with time t equal to 0. So what happens is, at time t equal to 0, I'm starting my production. Okay, so slowly my inventory is piling up. Okay, so during this period there is production as well as consumption. So whatever the remaining difference, that is your inventory, and it will be slowly piling up till it reaches a maximum value. So beyond this you don't have the capacity to store, and hence you will stop the production, and following that there will be only consumption. Okay, so the consumption is taking place slowly, and at one point it becomes 0. Right? So if you see the model 2, at this point you will start up your production, right? So here you don't start up your production, okay, and you have some amount of shortage. Okay, so inventory becomes negative. So at this point you are not able to meet up your customers' demand. At one point you are reaching a maximum stock out value. So this is the maximum negative inventory. Okay, so only after this you are starting up your production. So when you start up your production, first you have to satisfy this back order, okay, this stock out quantities. So first you have to make sure your inventory becomes 0, right? So slowly you are increasing your inventory, and at this point all your stock out quantities are met with the penalty. That is, you have completed the back ordering process, and now your inventory starts piling up. That is, inventory becomes positive, and the cycle goes again. So this is your entire till this point. Yeah, I missed it out. So this is your entire cycle time. Okay, so this cycle time consists of 4 components: T1, T2, T3 and T4. Okay, so T1 and T2, these terms are time periods during a positive inventory, and T3 and T4 are the terms during the negative inventory. Okay, so during the time period T1 you have production as well as consumption. Okay, so and you are reaching a maximum inventory, and during T2 you have only consumption. Okay, so till the point the inventory becomes 0, that is your T2 period. Okay, so from 0 to the maximum negative inventory, that time period is T3. So slope of this curve is still D, because you are extending this this demand, right? So during this period T3 there is only consumption. Consumption, but since you don't have the inventory, so that will be leading to shortage. So this is a period of shortage. And T4, right? So here what happens? Production starts, and during this time period the stock out quantities, that is back ordering, is satisfied first. Okay, so if I write if I want to know what are the time periods, I can just simply find out the slope of each curve, right? So the slope here is K minus D, right? So K minus D, and my y-intercept is I max and x-intercept is T2, right? So if I write the slope of here, that will be D, and my y-intercept will be I max and x-intercept will be T2. So I can find T1, T2. Similarly, in case of T3, here the slope is D, and my y-intercept is x max and x-intercept is T3. So T3 is x max by D. And similarly, T4 is, here the slope is K minus D, so S max by K minus D. So all you have to do is just remember this diagram. So if you are able to construct this diagram correctly, you can automatically write out the formulas. Then the economic order quantity is as simple as the last 3 cases. We have the Wilson factor. Since the production model, we have the production factor, and since we also permit shortage, we have the shortage factor. Okay, so I max is the Wilson factor into inverse of production factor into inverse of shortage factor. If you know the Q star, that is the economic batch quantity, and I max, you can determine the negative stock out quantity, that is Q star minus I max. We have derived the time periods. So the total inventory cost is the same as the first one, that is Wilson model, root of 2D C naught CC into inverse of production factor into inverse of shortage factor plus DCP. So remembering the formulas are very, very simple. All you have to do is remember all the 4 diagrams and purchase model without shortage models formulas. Okay. So we'll see some problems, and with that we'll conclude. So before reading the problem, make sure before starting the problem, make sure you have correctly identified the model. That is very important, because if you have identified the model wrongly and substituted the formula, then the entire problem will be wrong. Okay. So what they have asked here is the textile mill buys. So this is nothing but a purchase model. The annual demand is 9,000 units. So what they have given is the demand rate, that is 9,000 units per year. Ordering cost is 100. That is C naught is 100 per order. Carrying cost is 20% of purchase price per unit per month. Okay, so it is actually practically this is how the carrying cost will be estimated. It is some percentage of the purchase price. So what they have given is CC is rupees 2. That is purchase price is purchase price is 1, right? So CC is 20% of 20% of CP. Okay, the unit of CP is per item, but carrying cost also requires the time period, right? So let us see what is the time period given here. The time period given here is month. Okay, remember, before you substitute the parameters in the formula, all the time periods should be uniform. It is generally a good practice to use the time period as year. Okay, since demand is given as year, I want to convert this carrying cost also into year. So this is per month, right? So what I have to do to convert to year, I have to divide by 12, right? Since this is already in denominator, I will simply multiply by 12. So 20% is nothing but 0.2. 20% is 0.2 into, I'll be multiplying with 12. Okay, because the if you convert month to year, it should be divided by 12. Since month is in denominator, it will come to the top, that is numerator, that is 12. So 0.2 into 12, 2.4 rupees per unit per year. So let me repeat again. Before you substitute the parameters in the formula, make sure the periods are same. So if you are having year or month or day, make sure all the parameters have same periods. Okay, it is a good practice to follow it years. Okay, yeah. So they have asked the economic order quantity. So how I'm sure that this is not a purchase model with shortage is in this model they haven't mentioned any shortage cost. Okay, CS is not given. So automatically it means this is a purchase model without shortage. Okay, so substitute the formulas. So 2D C naught by CC. Okay, automatically you'll get the answer. Since this is a quantity, it should be an integer. So I am approximating to 866. So if you want to find the total cost, you can use this formula or simply root of 2D C naught CC plus DCP. Okay, if you use this formula, that is also fine, because this is a formula for total cost with respect to economic order quantity. Okay, next they have asked the number of orders per year. So D by Q, that is 10.39 orders per year. Okay, order is also an integer, so approximated. So 11 orders per year. Time between consecutive orders, yeah, so Q by D. Remember, we have the periods in year, right? So this should be year. You cannot approximate this to 0.01. Okay, so you have to convert this year into month. So multiply by 12. So that way it will be converted into month, and multiply by 30. That way it is converted to days. Okay, and then you can approximate. That is fine. That is 35 days. Okay, so if you find this process to be tedious, just multiply this by 365. Okay, year into days. Okay, this is very simple. You are just substituting the formulas. Now, if you see this problem, let us find what model it belongs to. So the annual demand is 9,000. So they have given the annual demand, and the carrying cost is 15% of purchase price per year. Okay, so all are in the same unit, so no worries. We have no need to convert the periods, and the purchase price is 20. Okay, so they have used symbol P. We have used CP. Okay, both are same. Ordering cost is 15 rupees. Yeah. Presently, the order size is the average monthly demand. Okay, so they are not following the EOQ model. They are having a different order quantity. So every time they make a order, they have a order quantity Q equal to monthly demand. Okay. Now they are asking us to find what is the EOQ and suggest which is better, that is ordering the monthly demand every time or ordering EOQ. Okay, so we have two cases. So in case 1 we have to find what is the cost associated with EOQ, and in case 2 we have to find what is the cost associated with the present ordering system, that is the monthly demand. Then we have to compare the two costs. Okay, so let us first find the EOQ, that is 300 units. Then let us find the cost with respect to EOQ. Okay, as I said before, you can also use this formula, that is 2D C0 CC plus DCP. Okay, so this is the total cost with respect to ordering EOQ, right? Now currently they don't follow the EOQ system, so they are following a system where they make an order size equal to monthly demand. Okay, so my Q value now is monthly demand. So they have given the annual demand to be 9,000. So my monthly demand will be 9,000 by 12. So that is my monthly demand. So I think this is 750 units, right? Now I need to find what is the total cost with respect to this particular ordering system. Now what is the mistake many make is they simply use this formula here. Okay, so this formula corresponds to total cost with respect to EOQ. Okay, so if you are finding the total cost with respect to different order quantity, you have to make use of this formula only. That is, separately you have to add it. This is the ordering cost, carrying cost and purchase cost. Okay, so here instead of the EOQ 300 units, you will be using 750 units. Okay, so please don't make a mistake here. This formula works only when the order quantity is equal to economic order quantity, that is Q star. When the order quantity is different, then you have to use this formula only. Okay, so they have asked us which is better. So if you use EOQ, your total cost is around 1,80,900 rupees. If you use the present ordering system, it is exceeding, that is 81,000. Okay, so you have a cost advantage of the difference between these two, 405 rupees. Okay.